2.66 million euros. Okay. And now what we also have to calculate is we have to calculate, well, let's actually calculate the cross product of the ranks times the salaries, GRYs. So we have 2 times 3.5 is 7, 1 times 6.7 is 6.7, 3 times 4.2 is 12.6, 4 times 1.7 is 6.8, 5 times 2.2 is 11. And we need a sum of those ranks. So let's actually sum them up. 7 plus 6.7 plus 12.6 plus 6.8 plus 11 gives us a total summation here of 44.1. So the sum of the ranks is 44.1. And finally, what we need is we need a standard deviation of the observations on the y variable. So don't forget, that would be the sum of the square distance that the observations are away from their own mean value divided by the sample size minus 1, and it's actually the square root of that. So what we should do is we should calculate y minus y bar, or minus the mean of the y squared values, and see how we get on. So for each one of these y values, we're going to take away 3.66 and we're going to square them. So we have 3.5 minus 3.66 gives us 0.16, and when we square that, we end up with a value of 0.0256. Then we have 6.7 minus 3.66 gives us a value of about 3.04, and when we square that, we end up with a value of 9.2416. We have 4.2 minus 3.66 squared gives us a value of 0.2916. 1.7 minus 3.66, and when we square that, we end up with a value of 3.8416. And finally, 2.2 minus 3.66, and when we square that, we end up with a value of 2.1316. And from a standard deviation perspective, don't forget the standard deviation is simply the sum of the squared distance that the observations are away from their mean value averaged, but it's an unbiased estimator, so we're going to divide by n minus 1, and it's the square root of that. So we're going to sum these values up here. So when we sum these up, 0.0256 plus 9.2416 plus 0.2916 plus 3.8416 plus 2.1316 gives us a total summation of 15.532. And let's just keep in mind that the variance, the standard deviation, SY, is the square root of the sum of the observations away from their mean value squared all over the sample size minus 1, and in particular it's the square root of that. So our SY is going to be equal to, it's 15.532 divided by, within the interval variable, small n is the number of observations, so it's going to be 5 minus 1, and it's the square root of that. So we end up with SY. The standard deviation is, let's just do that really quickly. So it's the square root of 15.532 divided by 4, which gives us, oh, that's an error. So it's the square root of 15.532 divided by 4 gives us a value of approximately 1.97, let's say 1.9705. Okay? So now we know this, it's 1.9705. So now we can calculate this particular correlation. So let's just put that down again. So our correlation formula, once again, let's say it's R subscript Ri, and as we said, it's the sum of the cross product of the ranks with the interval scores all over the number of paired observations minus the number of paired observations plus 1 over 2, which needs to be multiplied by the mean on the y variable, divided by it's the square root of n squared, the number of paired observations, minus 1 over 12, which then is multiplied by the standard deviation of the y variable. So we have all of our values. So we have R or I becomes the sum of the cross products is 44.1 divided by the number of paired observations is 5 minus the number of paired observations is 5 plus 1 over 2, which needs to be multiplied by the mean, which is 3.66, which needs to be divided by the square root of the number of paired observations